On the morning of July the 1st, 1916, along a 25-mile stretch of the Somme River in northern France, 14 British divisions climbed out of their trenches at 7:30 in the morning and walked toward the German line under what their own commanders believed was near total artillery cover. By the end of that single day, the British Army had suffered 57,000 casualties, the single bloodiest day in its entire multi-century history, and roughly 21,000 of those men were dead or dying before nightfall fell across the battlefield. Most of them were killed by one weapon, a water-cooled, belt-fed German gun called the Maxim 8, capable of firing 500 rounds a minute out to 2,000 yards, and a handful of well-placed guns like it could stop 2 entire battalions in the open ground of no man's land. That gun was already 32 years old on the day it did that. On that same morning, on the other side of the Atlantic Ocean, an American gunsmith in his early 60s had a nearly identical mechanical idea sitting untouched in a drawer, patented decades earlier, tested only on paper, and completely unwanted by his own government for 27 years running. He would not pull it off the shelf for another 8 months. This is not a story about which man built the better machine gun. It is a story about the 33 years that separated the weapon that caused the deadliest single day in British military history from the weapon built far too late to answer it. Every week we take apart the story behind an American weapon, the inventor, the proving ground, and the war that decided whether it mattered. Subscribe if that is the kind of history you want more of. Hiram Maxim was born on February the 5th, 1840 in Sangerville, Maine, the eldest son of a poor sheep farmer who was also the local mechanic. His entire formal education amounted to roughly 5 years in a one-room schoolhouse. At 14, he was apprenticed to a carriage maker, and from there he simply kept moving, taking whatever job let him keep, inventing, building an automated mousetrap design still recognizable in hardware stores today, working in gaslighting and locomotive headlamp design, and eventually becoming chief engineer of the United States Electric Lighting Company in 1878. Where he developed a method for manufacturing carbon filaments that put him in direct and bitter competition with Thomas Edison over who had actually invented the incandescent light bulb first. Maxim always maintained he had built working bulbs in 1879, a year before Edison's patent. Nobody settled that argument in his favor, and by the time the dispute had cooled, Maxim had already begun looking for a field where nobody else could claim to have arrived first. In 1881 he moved to London, and it was there, according to the story he told for the rest of his life, that an acquaintance gave him a piece of advice that changed the direction of his career entirely. If he wanted to make real money, the man told him, he should invent something that would let Europeans cut each other's throats with greater efficiency. Maxim, by his own account, took the suggestion literally. He had a personal memory to draw on. As a boy, he had been knocked flat by the recoil of a rifle, and the sheer physical force of that memory stayed with him for the rest of his working life. Between 1883 and 1885, he patented 3 separate ways to harness that same recoil energy: gas operation, blowback, and true recoil operation, to cycle a firearms action automatically without a soldier needing to work a bolt or a lever by hand between shots. He settled a large house in West Norwood in South London and began building a weapon around the recoil principle specifically, warning his neighbors in the local newspaper that he would be test firing in his garden and that they should leave their windows open so the vibration would not shatter the glass. In 1884, he had it working, a single-barrel, belt-fed, water-cooled gun that used the force of its own recoil to eject the spent case, load the next round, and fire again, For as long as a soldier held the trigger and the water jacket kept the barrel from warping under the heat, it fired roughly 11 rounds a second. The British government's initial reaction was, in the words of the officials who reviewed it, that it needed perfecting before they would consider adopting it, and that there was little point using 50 bullets when one would do. Maxim founded the Maxim Gun Company that same year anyway, with outside financial backing, confident that the rest of the world would eventually see what his own adopted government could not yet see in front of it. 6 years earlier, and an ocean away, a different kind of education had already produced a very similar instinct in a very different young man. John Moses Browning was born in 1855 in Ogden, Utah, the eldest son of a pioneer gunsmith named Jonathan Browning, who had crossed the frontier with the earliest Mormon settlers. And John grew up inside his father's shop the way Maxim had grown up on a sheep farm, handling parts before he could properly read, learning the physical logic of moving metal before he had learned much of anything else. He built his first working gun at 13. At 23, working from a design his father had reportedly challenged him to improve, he patented a falling block single-shot rifle and sold it to the Winchester Repeating Arms Company for $8,000, the start of a career that would eventually touch nearly every major American arms maker of his era: Winchester's lever-action rifles, Colt's early automatic weapons, and eventually the Belgian firm Fabrique Nationale. Then in 1890, just 6 years after Maxim's original patent across the ocean, Browning patented an automatic machine gun of his own, cycled by the same underlying principle Maxim had already proven: the energy of the gun's own recoil. The two men had arrived at nearly the same mechanical idea within a single decade of each other, independently on two different continents. One a self-taught Maine farm boy who had crossed an ocean to sell death more efficiently to Europeans who were happy to buy it. The other a devout craftsman's son from the American frontier who built almost everything else first and treated the machine gun as one invention among dozens. What happened to those two ideas next is where their stories stop rhyming and start diverging by exactly 33 years. Nobody in the peacetime United States Army wanted Browning's recoil-operated design in 1890 for the same reason the British War Office had hesitated over Maxim's a few years earlier. A small standing army with no active war in front of it saw little reason to invest in an untested and expensive new class of weapon. Browning went back to designing rifles and shotguns that were actually making him money, and his recoil-operated machine gun sat on a shelf, patented, proven only on paper, entirely unwanted, for 27 years. Maxim's gun took the opposite path almost immediately. Where Browning found indifference, Maxim found a world full of governments eager to buy exactly the kind of overwhelming, one-sided firepower his invention offered, especially against opponents who had no machine guns of their own to answer with. Maxim's company merged into the British armaments giant Vickers, and Maxim himself became a director of the combined firm, knighted, wealthy, and naturalized as a British subject. Long before it ever reached a European trench, his gun had already been tested repeatedly and lopsidedly in colonial campaigns across Africa and Asia, where a handful of Maxim guns in British, Belgian, or German colonial hands could decide an engagement against forces armed only with older rifles or none at all. Historians have since called it the weapon most associated with imperial conquest during that period, and the lopsided casualty ratios it produced against poorly armed opponents gave European military planners a dangerously incomplete picture of what the weapon would do once both sides of a battlefield finally had one. His original patent expired in 1900, and rather than ending his design's reach, the expiration multiplied it. Freed from exclusive licensing, variations on the Maxim mechanism spread across Europe, refined by Vickers into the British Vickers gun, and licensed into Germany, where the arms manufacturer DW adapted it into a weapon formally adopted by the German army in 1908, the Maschinengewehr 08, the MG-08 for short. When the First World War began in August of 1914, Germany already had roughly 12,000 of these guns in service, built at a modest rate of about 200 a month. The German High Command did not yet fully grasp what it was sitting on. Neither, at that stage, did anyone else. Military observers who had watched the Russo-Japanese War a decade earlier had concluded that machine guns were an overrated novelty, unlikely to matter much against properly trained European soldiery, since the men doing the observing did not consider Russian or Japanese conscripts to belong in that supposedly elite category. That assessment did not survive contact with the Western Front. By 1916, German factories were producing 3,000 MG-08s a month. By 1917, that number had climbed to 14,400 a month, an industrial output that would have been unimaginable to the British officials who had once told Maxim his gun needed perfecting before anyone would bother adopting it. More than 2/3 of all the small arms ammunition Germany fired during the entire war went through machine guns rather than rifles, a statistic that says almost everything about which weapon actually shaped how the war on the Western Front was fought. What that industrial scale actually meant for the men walking toward it became unmistakable on the first morning of the Battle of the Somme. The MG-08 weighed a little under 60 pounds, fired 7.92 millimeter rounds at 400 to 500 a minute, and was accurate out to 2,000 yards, with a maximum range twice that far. French soldiers who faced it called it the lawn mower or the coffee grinder. British soldiers called it the devil's paintbrush. British commanders under General Douglas Haig had planned the Somme offensive around a straightforward theory: a week-long artillery bombardment, more than 1.5 million shells fired into a 30-mile stretch of the German line would either kill every defender in place or leave the survivors too shattered to resist an infantry advance. The Germans had spent months building deep dugouts, tunneled far enough underground that the shelling barely touched them, and machine gun emplacements reinforced with earth and stone behind dense belts of barbed wire. On July 1st, 1916, the moment the barrage lifted, German gunners climbed back up into positions the British High Command had assumed no longer existed, set up their MG-08s, and waited. 14 British divisions advanced across open ground in daylight, in most places unable to keep pace with the creeping barrage that was supposed to be clearing a path ahead of them. A single well-positioned gun crew, properly supplied with ammunition and water for the cooling jacket, could stop an entire advancing battalion on its own. By the end of the day, the British Army had lost 57,000 men killed, wounded, or missing, and roughly 21,000 of them were dead. The worst single day of casualties any British Army has ever recorded, before or since. One junior officer in the Royal Irish Rifles described what he watched happen to his own company in stark, simple terms. The German machine guns had not been eliminated. They opened up accurate fire, and the men simply got up and fell back into the trench, either killed outright or badly wounded. Historians still debate exactly how much of that single day's slaughter is attributable to machine gun fire, specifically rather than artillery fire, falling short, or barbed wire that the week-long bombardment had failed to cut. But no serious account of the Somme leaves the MG-08 out of the explanation, and few dispute that it was the single weapon most responsible for turning an infantry advance into a massacre in the space of a few short hours. The offensive itself dragged on for another 4.5 months after that first morning, grinding to a halt in the November mud, having gained only a few miles of ground at a combined cost on both sides of well over 1 million casualties. Sir Hiram Maxim did not live to see any of that offensive's end. He died on November the 24th, 1916, in his home in Streatham, London, 76 years old, wealthy and celebrated. A few weeks after the Somme finally ground to a halt, the war his own invention had helped make possible was, at the moment of his death, still only a little more than halfway through. 8 months before Maxim's death on the other side of the Atlantic, the shelf that had held Browning's 27-year-old patent finally mattered again. When the United States formally declared war on Germany On April 6, 1917, the American Ordnance Department's own internal accounting found the entire nation possessed fewer than 700 aging machine guns of any kind, nowhere near enough to send an army into a war that the Somme had already proven, at horrific cost, was above almost everything else a machine guns war. American commanders who had watched the Western Front from a distance for 3 years understood, at least on paper, exactly what kind of weapon they were now racing to build, a domestic answer to the same water-cooled, recoil-operated principle that had already killed and wounded tens of thousands of British soldiers in a single morning. Browning, now past 60, pulled his old recoil-operated design back off the shelf and, working with his son Val, had it firing reliably again within weeks. On February the 27th, 1917, at Congress Heights, south of Washington, he demonstrated it in front of roughly 300 congressmen, senators, and military officers, men who had spent 3 years reading dispatches about exactly the kind of slaughter a gun like this could produce, and were desperate to know whether America finally had an answer of its own, alongside a second, lighter design that would become known as the Bar. Both weapons worked without a single stoppage. Within weeks, he had a government contract, and within months, the Army would ask his design to do something no machine gun trial had ever demanded before: prove that a frightened soldier could strip it down and reassemble it, blindfolded, unable to see his own hands. Further trials at Springfield Armory that may push the design harder than any single afternoon in Washington had. Browning fired the first prototype for 20,000 rounds without one malfunction. The skeptical board asked for more, and a second gun fired continuously for 48 minutes and 12 seconds, more than 21,000 rounds without stopping. The same basic principle Maxim had proven 3 decades earlier: a water jacket carrying heat away from the barrel faster than the gun could generate it, now refined into a mechanism with far fewer parts to break, jam, or freeze solid in a European winter. Then the board asked for the blindfold test, and the soldiers passed it in minutes, a small ritual that would outlive the war, the man who designed it, and most of the soldiers who first performed it. The Army adopted the weapon as the machine gun, Browning caliber .30, model of 1917, and sent manufacturing contracts to Colt, Remington, and New England Westinghouse simultaneously, an arrangement that reflected how badly the government needed volume rather than a single trusted supplier. It was still not fast enough. Tooling up 3 separate factories to build a precision, water-cooled weapon with parts that had to interchange cleanly between them took time the front line did not have. American troops in France spent most of 1917 and well into 1918 fighting with borrowed French Hotchkiss guns, while Browning's design was still being tooled up back home. The first model of 1917 guns were not even demonstrated to officers in France until the end of June 1918, barely 4 months before the armistice. Of the roughly 30,000 guns that eventually crossed the Atlantic, only a little over 1,000 reached the front in time to fire at a living enemy before the guns fell silent on November the 11th. The gun built to answer the weapon that had already defined the war arrived with just 6 weeks left to prove itself. Those 6 weeks were enough to leave a mark, even against a design that had already been killing men for 2 years by the time it showed up. A machine gun detachment of the Army's 78th Division reported directly to General John J. Pershing that its 4 guns had fired roughly 13,000 rounds across 5 days of action, sustained fire that no air-cooled weapon of the period could have matched without burning out its own barrel. The heaviest use came during the Meuse-Argonne offensive that autumn, the largest and bloodiest American operation of the war. A 47-day advance through dense forest and fortified German positions that cost more American lives than any other battle in the nation's history, where sustained defensive fire held captured ground against counterattack and broke up German assaults before they could close to grenade range. It was, in miniature, the same water-cooled principle that had cut down the British Army on the Somme 2 years earlier, now finally in American hands. Arriving at the tail end of the same war that principle had already shaped from the opposing trench. facing down machine gunners on the other side who were, in a strange and mostly unremarked way, operating direct mechanical descendants of the very same 19th century patent Browning himself had been chasing since 1890. Maxim never saw any of it. He died knowing only the earlier half of what his invention had done. The somme verdun, 2 years of a stalemate, his own recoil-operated mechanism, had done more than almost any other single weapon to create. And he did not live to see the war end, let alone see an American answer finally arrive in the trenches. His own design's German descendants still occupied. He left behind a title, a fortune, a directorship at one of Britain's largest arms manufacturers, and a name permanently attached to a category of weapon rather than a single product, the way later generations would speak of a Colt or a Winchester. Browning outlived him by exactly a decade, dying in 1926 at a workbench in a Belgian arms factory owned by Fabrique Nationale, working on an entirely different design at the moment his heart finally gave out, having watched his own machine gun outlast the war. It barely joined and become, through the 1920s and 30s, the standard the entire American military built its heavy weapons doctrine around. One inventor died in the middle of the horror his design helped cause, wealthy and celebrated in a country he had adopted, specifically because it was more willing than his own to pay for what he could build. The other died as an old man still working in a country not his own either, having lived just long enough to see his own answer to that horror settle into permanence, rather than fading as a wartime footnote nobody bothered to remember. Both mechanisms outlived both men by a very long margin. The Vickers gun, Britain's own refinement of the Maxim principle, remained in official British Army service for another 47 years after Maxim's death, not retired until 1963, nearly half a century after the recoil-operated action it depended on was first patented in a South London garden. It fought through the Second World War, through Korea, and into colonial and post-colonial conflicts across the very same decades. A soldier who had never heard of Hiram Maxim was learning to strip a Browning blindfolded on an American parade ground. Browning's model of 1917 was updated into the model of 1917 A1 in the late 1930s and fought again through nearly every theater of the Second World War into Korea and with South Vietnamese forces into the 1960s, more than 4 decades after Browning first pulled his own old patent back off the shelf. The same recoil-operated action, lightened and made air-cooled, became the M1919 machine gun of the Second World War and scaled up to .50 caliber. It became the M2 Browning, a weapon still in active American military service today, more than a century after Browning first patented the underlying idea in a country that had no interest in it, yet, in more than a century after Maxim proved the same underlying principle worked at all on a different continent, for a different government, in a different kind of war entirely. This is not a story about which inventor built the better weapon. It is a story about how little the quality of an idea has to do with when the world finally decides it is ready to use it. Maxim's recoil-operated principle took less than 4 years to go from a South London garden to a standing order from a European government, and 32 more to become the deadliest single mechanism of the 20th century's opening decades. Browning's nearly identical principle took 27 years to leave a drawer, and by the time it did, the war it might have shaped from the beginning was already 6 weeks from over. Somewhere today, in a museum case in London or Leeds, a Vickers gun sits behind glass beside descriptions of a battle that ended before most of the visitors reading those descriptions were born, its water jacket long since drained, its belt feed silent, a design that once decided whether an entire battalion crossing open ground would live to reach the far trench. Somewhere else entirely, on a vehicle or a fixed mount in active service with the American military, an M2 Browning still cycles on the same basic principle, a Maine farm boy and a Utah gunsmith's son, both discovered independently, an ocean and a working lifetime apart, without ever needing to meet each other to arrive at the same idea. Maxim proved that recoil could kill at a scale no army on earth had previously imagined, and the world spent 30 years learning that lesson the hard way before it finally turned that same principle over to the very soldiers it had been used against. Browning proved that the same underlying idea could still be refined, simplified, and trusted decades later by a frightened soldier who could not even see his own hands. Neither man started the war that made both their names. Both of their machines finished shaping how it, and nearly every war fought after it, would actually be decided. If you want more stories about the inventors and rivalries that quietly defined how America and the world fight their wars, subscribe, and we will keep finding them. See you in the next one.